Let's finish up talking about chapter 6, and this is section 3, about the binomial random variable. Now, in this binomial setting, you want to say, well, what is our expected value? And we write this like this. It's the mean and expected value, pretty much the same thing. So mu of x is going to be really just the number of items that you're looking at in your sample, I guess, and you're going to multiply that by the probability. So let's just say you go to, how about we say that on average, about 8% of the population have red hair. So you go to a town and you want to test this, and you go to a middle school and you check out the population of that middle school, and you expect that 8% of those kids would have red hair. Now, you go to this middle school and say they have 600 kids. So that would mean that, well, 8% of those kids, of those 600 kids, would have bright red hair, and I'll figure that out. So you would expect to see 48 redheaded kids in that school, based on that statistic, the probability that it's 8%. Now, what about the standard deviation? Now, standard deviation is a little bit different, and of course, we're going to write this out, standard deviation, and here's the formula. So you take the square root of the number of items in your sample, and you're going to multiply that by the probability, and 1 minus the probability. So in this case, you would take the square root of, well, there were 600 kids, and you're going to multiply it by 8% of the kids have red hair, and also the other 92% are going to have some other color hair, right? Either red hair or not red hair. Yes, no. It's a binomial situation. So let me see what that number is. And that number turns out to be 6.65. So that's what you could expect to be off by on average. 6.65 kids higher or lower than 48 kids with red hair. So let's take a look at something else on this matter. Now, something else we talked about was that 10% rule. We looked at 600 kids, binomial random variable. We set the number ahead of time. But the situation is that we can't take a sample that's any more than 10% of the school. So in this case, we would have to assume that this giant middle school, sounds like a nightmare, would have to have 600. Can you imagine that? Actually, 6,000. 6,000 7th and 8th graders. Ugh. Anyway, that's what we would have to assume in this situation, and we'd have to show that in some way. Now, there's something else, and that is that we have to figure out that the number in our sample times the probability has to be at least 10 or greater, and then also the number times 1 minus the probability also has to be at least 10. So those three things, the 10% rule, I'm going to write that down, 10% rule, and then also these other things that give us a normal approximation, which allows us to use the binomial random variable. So in this case, it would be 600 times 0.08, which is definitely bigger than 10, and 600 times 0.92, 0.92, which is also much bigger than 10. So we're safe in those regards. Okay, let's talk about the last thing, which was the geometric probability. Let's talk about that birthday problem that we did in class. Now, this is a geometric probability situation where you keep doing trials until you get one success. Now, the situation was, guess what day my friends were born on, and each friend is different, and it could be a different day or not a different day. You don't know, but you're just going to keep guessing until you get it right. Now, let's just say that you get it right on the fourth try. The probability that you get it right is 1/7, because there's 7 days in a week. You have a 1 out of 7 shot of guessing the right day. And of course, you have a 6/7 shot of guessing the wrong day. So, given the fact that we guessed the correct day in 4 tries, so we would say we guessed correctly on 4 tries. And we guess wrong 3 times. 3 out of the 4 times we got it wrong, and then on the 4th time we get it right. So that would be 6/7, right? Because we have a 6/7 chance of getting it wrong. And we guessed that 3 times. And then on the last guess, we got it right, and that's a 1/7 chance. So that's how you do geometric probability. You have how many times did you get it wrong, and you get it. Maybe I should write that down. You have a right there, right? Because maybe that's a little bit clearer. 3 and 1 gives us 4. 3 wrong guesses, 1 correct guess. 1/7 chance of getting it right, 6/7 chance of getting it wrong. Hopefully that, if you remember that activity, and maybe later on you can look back at this video and say, oh yeah, huh? Okay, bye.